In this video, we're going to be starting our material on amines and amides. The learning objectives for this chapter are similar to the previous chapters that we've covered. We're going to be identifying our functional groups for amines and amides, classifying our molecules, naming them, predicting relative boiling points, acid and base behavior, and then talking about chemical reactions that these molecules participate in. Let's get started by talking about our structures of amines so that we can perform our learning objectives for identifying molecules containing amines and amide functional groups, and also classify amines as being primary, secondary, or quaternary. Amines are, what happened? Amines are carbon organic derivatives of ammonia. So ammonia has a chemical formula of NH3, as shown here. Nitrogen has 5 valence electrons, and so it has 3 available spots for bonding to 3 hydrogens. That gives the nitrogen a lone pair that just belongs to it, that's not participating in bonding. Carbon can bond to nitrogen in one of those locations, and so amines can be classified as either primary, secondary, or tertiary, depending on how many R groups there are. So if there's only one carbon something or other, it's the primary. If there's 2 carbon groups on that amine, then it's secondary. And if there's 3 carbon groups on that amine, then it is tertiary. A quaternary ammonium cation has 4 different groups on it. And so this could be either 4 different carbon groups or a combination of hydrogen and carbon groups somehow. Ammonium is positively charged because the nitrogen has too many bonds on it. Neutral nitrogen has 3 bonds. If nitrogen has more bonds than it does when it's neutral, then it is positively charged. And so you're expected to know that that nitrogen with 4 bonds is positively charged. You can think of it as like our other cations, like sodium, potassium, calcium. Those are all positively charged ions when they form compounds. Ammonium also is positively charged. Let's look at the structures of amines. When we do draw our line structures, we're used to omitting hydrogens that are bonded to carbon. But you do have to show any hydrogen atoms that are bonded to heteroatoms, such as oxygen or nitrogen. That means that when we draw our amines, we have to make sure that we explicitly write out how many hydrogens there are. You can see here, this is a secondary amine, but this is a tertiary amine. This is a methyl group off of that nitrogen. And so if we write an H on there, then it's a hydrogen. If we leave the H off, it's a methyl. And so we have to be very clear that we're always writing our H's on our nitrogens. The H's always have to be shown they're bonded to the nitrogen. Let's draw our condensed structural formulas. So here, this molecule, we can see that this molecule has a CH3 group. It has a CH2 group. This is an NH group. This is a CH2 and a CH3. So this molecule can be represented like this. But you'll notice that this group and this group are identical. And that means that we can group them together around the nitrogen. And so we can write this as CH3, CH2, 2, and then NH. So we can group those together. And so if we are doing a tertiary amine, we can use parentheses to indicate where a branch is coming off of the nitrogen. For instance, draw the line angle structure for this molecule below. Go ahead and pause the video and try to draw the line angle structure. When you're done drawing, unpause the video to compare your answer to what I draw. All right, let's go over this. So I'm supposed to be drawing a line angle structure. I can see that we start off by drawing 3 carbons. And so that's 1, 2, 3. Now I have to draw a bond to a nitrogen. This is in parentheses, and so this indicates a branch that comes off the nitrogen. So that's a methyl group. And then I have an ethyl group. And so I go 1, 2. And so I have 3 carbons over here, a methyl hanging off of it, and then an ethyl hanging off of it. Let's classify this molecule as either being primary, secondary, tertiary, or quaternary. This molecule has 2 carbon groups hanging off of it. 1, 2. So this is a secondary amine. 2 carbon groups makes it secondary. What about this molecule? Primary, secondary, tertiary, or quaternary? This molecule is quaternary. You might have been able to tell that because of the positively charged ion indicated by the positive charge here. But we could also count the carbon atoms. This 3 means that there are 3 methyl groups on there. And so really it's CH2, N, CH3, CH3, CH3. And we can continue with the chain here. What about this molecule? Primary, secondary, tertiary, or quaternary? This molecule has 1, 2. That's not where the nitrogen is. The nitrogen is here. This molecule has 1, 2 carbon groups. This one is secondary.